List of v6 peerings for us and for LavaNet. UH has, of course, TW Telecom, which I talked about, and that's our only commodity peering. Pacific Northwest Gigapop, DREN, and RNet are all REN networks, and then the Hawaii Internet Exchange is an internet exchange in Hawaii. So ISPs and organizations in Hawaii can exchange packets without sending them through the mainland. Now LavaNet, of course, has kind of a different setup. They have multiple commodity peerings, some of them through tunnels with Hurricane Electric, Sprint, AT&T, Verizon Business. TowardEX is a hosting company, and of course the Hawaii Internet Exchange. So currently, LavaNet is the only commercial v6 peer with the Hawaii Internet Exchange. But this is really encouraging, since there are several carriers that are ready to do v6. So it would be a little bit of a problem to set up a v6 network if there was no connectivity out to the world, or only tunneled connectivity out to the world. But there are various carriers willing to move forward. LavaNet IPv6 status, as I said, they have multiple v6 peers. All services and most office workstations are all v6 enabled. Their DNS hosting for their DNS on behalf of their customers, and they deliver v6 to DSL and frame relay customers upon request. Our short-term goals include getting our DNS completely working with v6, full services in v4 and in v6 packets, and our workflow for DNS and address management. You're going to find that as you deploy IPv6, after you get it working, then you want to make it full production. You want to manage it in the same way, or similar ways. You want to find ways to manage it that work for you alongside IP version 4. Another goal is to dual stack all IP routing. Currently we're at about 99%, and dual stack all public facing services. Currently we're at about 5%, but we are planning to move that ahead as well. Mail, I wanted to give you a view of the mail system at the University of Hawaii, because it's very complex, and many things are very easy to turn on IPv6 for, but mail at the University of Hawaii is not an example of that. Careful planning will be necessary. Training the email system admins will be necessary. And when email is not flowing, a crisis is occurring. It's supposed to work 365 days a year by 24 hours a day. And if mail is not flowing, it's usually piling up somewhere or eventually getting rejected. And this is a major concern of ours. If there's any kind of link outage or power outage or et cetera, is that mail piles up, and once the threshold that things started getting returned is reached, then you start losing mail, and mail doesn't get delivered. So it's the point being, if we're going to move forward and affect mail and move it to IPv6, we need to do it very carefully, and we need to keep our eyes wide open. This is a representation of sort of how our mail system looks. At the top you have a load balancer, and underneath 3 MX machines which accept email for hawaii.edu. Then you have another load balancer and 3 MTA machines which accept email from clients, as well as doing email client mailbox access for our users. And there's 3 mailbox storage machines at the bottom. And this isn't a simple gravity feed hopper system. Sometimes mail that's submitted to the orange host will flow back up to the blue host to be spam filtered, and then flow back down. And there's some moving around within this picture. That's it's not a simple linear progression. Cost is a major issue for a lot of people considering IPv6, but as I have said before, cost can be controlled. IPv6 is not value-added software. You need to remind your vendors of this. Cisco has never charged for it as far as we've seen, although apparently you had to pay for the feature set that included IPv6. Cisco now has converged their IPv4 and IPv6 feature sets, and they're offering them together. So they're being progressive about making v6 available to everyone. Juniper did charge for it as a feature for a while, but they've stopped charging for it. Most of our costs and LavaNet's costs are in staff time and training. LavaNet has participated in open source projects and contributed IPv6 code back to the open source projects. Cost can be controlled if you simply place v6 on your requirements list, start requiring it, and don't panic. The Big Island router memory redesign is by far the highest cost IPv6 deployment measure so far. We had to, on the Big Island of Hawaii, we had to replace some Cisco 3750s with fixed memory configurations with, we had to reconfigure them and buy a Juniper M7i in order to have it do most of the work of peering and routing with the external internet from the Big Island. Of course, there are different ways to do that, and it's not necessarily Juniper is not necessarily the only solution. But on the Big Island, we have limited space, and we're given some space in other organizations' facilities. So space and power and access are concerns, so we bought something small. Something that you will run across if you look at your network right now, almost certainly, whether you've deployed v6 or not, is tunneled forms of IPv6. There's Teredo, from which we see significant incidental traffic. It's included with the Windows's XP, Vista, and 7 so far. It may be included with the server distributions as well. It is made to be used from behind a NAT. It's designed to enable IPv6 tunneling from behind a network address translation device, and it may also work from not behind a NAT. I don't know, but it's probable that when you see Teredo traffic, it's coming from behind a NAT device. There's also 6-4, from which we see some incidental traffic. It's included with Windows and Mac OS. It tunnels via a well-known address, usually 192.88.99.1, and it just finds whatever the closest instance of that address is to you. So the closest instance to us right now is LavaNet. So if someone uses 6-4 on our network, they end up tunneling through LavaNet. Previously, before we had it in Hawaii, a 6-4 client would end up tunneling through Pittsburgh or Indianapolis, which is certainly non-optimal. There's also Isotap, which is not among the automatically configured tunneling schemes with typical operating systems, but it's worth mentioning because it's a more sophisticated version of the same scheme as 6-4, and it's preferred for some things.